All right, by the end of class, you can graph a rational function and identify intercepts and asymptotes. Basically, you can graph a rational function, or you should be able to graph a rational function and identify key features. This is straight out of your packet. In your packet, it talks about a new family of functions we're going to study. This isn't on your paper. A new family of functions that we're going to study. At this point, it's the family of rational functions. Y'all covered that in last year, right? I hope so. I sure hope so. Yes? Y'all did rational functions? Okay. Awesome. Well, I know we cover it in on-level algebra 2, so I have to believe that everybody was exposed to rational functions. And rational, like you can think of the word ratio, and so it's always going to be where you have x in the denominator is really what it is. So you almost like having two functions where f of x and g of x are polynomials, and you divide polynomials and you get a rational function. One of the most important properties of rational functions is the presence of asymptotes, both vertical and horizontal. In the following exercises, we're going to try to deduce where these asymptotic lines appear. We define an asymptote as a line such that the distance between the graph of the curve and the line approaches zero as they tend to infinity. Basically, asymptotes are very attractive. Your graph is going to get arbitrarily close to, but never touch your asymptotes. So this is just kind of some introduction to rational functions. When you get your packets, when they come in, I didn't figure that we had to have them by today. We're okay. We can keep going. But this is the first page in your packet. So on your supplemental notes, up at the top, it says vertical and horizontal asymptotes. I would like for you to take a moment and jot this stuff down in whatever way you would like. But these are pretty important things. Hopefully, it is a review of what you learned last year. I'm going to shut up and let you copy.
No, you said the most difficult units.
I don't feel like that they get progressively harder, in my opinion, if that's what you're asking. I
don't either.
Well, so this unit we have, we're gonna do rational functions, limits, rate of change, a little bit of derivatives. I don't think this unit, I mean, rational functions can be hard for some students, but if you learned it last year, this unit is not that bad. And then next is parametrics and polars, which is gonna be new, probably new. I don't think y'all do that in Algebra 2. So, but I mean, I don't think that it's, oh, vectors come up next unit. Most students are good with vectors. I feel like we've probably already done it. For most students, I think. I think most students have the hardest time with the two trig units. Probably. The two trig units. 4A and 4B. I would say that the units aren't harder. I would say that it's more like that we're getting towards the end, so most students don't have as much energy. So it's not that they're harder, that students maybe get a lower grade. It's more like the effort that they're putting into it, or like they're busy with AP tests or lost their will to move on. Also, for anybody that's ever interested, I have a plethora of colored pens, even erasable colored pens, that you are welcome to use anytime you ever ask. I have pens, highlighters, markers, all kinds of fun stuff. All right, I was kind of basing this all on how quickly Hayden was writing it down, because I feel like you were taking the most time, like thoughtfully writing stuff down. So I feel like, are we done? Yeah, okay, let's move on. So this is all important stuff. When you have vertical asymptotes, those are looking in the denominator. Your asymptotes are when x is equal to 0, or when you look inside the factors, it's usually the opposite, and we'll kind of go over that. So when you are looking at those factors, more often than not, this is the situation that you have, where you have linear factors, that the exponent is typically a 1. We don't write a 1. And it could be a 1, 3, 5, 7, 9. Any odd multiplicity, which is, again, usually 1. Anytime you have an odd multiplicity around an asymptote, the two branches are going to move apart. So that means that, like, as your graph approaches that asymptote, they don't cross the asymptote. They're going to go apart from each other. So they will hit the asymptote and go apart, or not actually hit it. What happens sometimes, though, is that when you have an even multiplicity, and it doesn't have to be 2, it could be 2, 4, 6, 8, 10. It could be any even multiplicity. What that does to your graph is that when it hits the asymptote, your graph will go together in the same direction. So they either go together up or they go together down. They hit that asymptote, not actually hit the asymptote. As they approach the asymptote, they're going to leave and go together in the same direction. Horizontal asymptotes. This is also referred to as end behavior. Your end behavior, it's what's going to happen to your graph over in infinity land. So it's what happens far out. That's why it's called end behavior. And this depends on the degree of the numerator and denominator. We're looking at them like a ratio. And so this is what happens, I would say most often, it's this situation. So when you've got a big bottom, and this is how I remember it. When you got a big bottom, it's 0. You got a big old bottom, it's 0. Y is equal to 0. That is what happens more often than not. If you got a big bottom, then the horizontal asymptote is y is equal to 0. And so what I'm looking at is the degree. So as long as you've got a higher degree on the bottom, your horizontal asymptotes y equals 0. Also, your vertical asymptotes will always be x equals equations. Your horizontal asymptotes will be y equals equations. Okay, the next situation that can happen, and these are in no particular order. The next situation is that you have the same degree on the top and the bottom. And in that case, it's the ratio of the leading coefficients. And so it's the ratio of the coefficients. And when you're written in standard form, that's where you would find them. So y is equal to the ratio of a to b. And last, this does happen. I would say that more often than not, when you have to divide, I think mostly you could use synthetic division to divide, but that is certainly a skill that we have to recall from last year, is how to divide rational functions or divide polynomials. And that happens when when the degree is bigger on the top. It's not super often, but it does happen. And instead of getting a horizontal asymptote, it's actually a slant asymptote. And now the slant asymptote could actually be like a parabola. It could be anything. It could be sometimes it's a parabola. Most often it's a line, but it could be anything. Okay, moving on. And that's also another video that you could find, how to divide polynomials. I have that posted. I teach that in Algebra 2. Today, you are going to become a gangster grapher. So this isn't fun stuff. So this is as fun as I could make today's lesson. So you're going to become a gangster grapher. Find your gangster grapher name. I forgot to write mine down. Let's see. You've got two options. I don't think my favorite color is not there. My favorite color is glitter or pink, but I don't see it. Okay, I don't like my name on the left. That I do know. Okay, I would be the Dark Slayer. I don't know if I want that to be my gangster name. I would probably want something really cute. Like Crazy Bubbles or something like that. That would probably be more likely my gangster name. But in any case, I thought that would be fun. Did anybody get a good one? Not impressed? You're not feeling very gangster? Nobody's going to take us seriously. Anyways, I thought it was fun before we get started to be a gangster grapher. There we go. We'll become a gangster grapher. Okay, well, if you're really struggling, you can tell yourself that, like, I am a gangster. I can do this. I am a gangster. I can do this. All right, so moving on. This is the exploration that's in our packet. It says sketch the graph for each function below, sketch any vertical asymptotes as dashed lines, fill in the missing information, then make a hypothesis about where the rational function will have vertical asymptotes. Okay, let's do this. I'm going to kind of lead you through it because I know it's been a long time since we did this. So I'm going to kind of jog your memory. We have to remember this is really important. You want to make sure you factor first, maybe write that down so that it's fresh in your brain. We need to make sure that we factor first. So when I look at the first problem, and these are all really simple rational functions. When I look at the first problem, is it factored? I mean, you can't do anything with 1. Is x minus 1, is that factored? Yeah, it's factored. And a lot of times these are factored. Sometimes they're not, but a lot of times that they are. So what we need to remember is that the numerator helps us find the x-intercepts, and that the denominator helps us find vertical asymptotes. And so I'm going to jot that down. So my x-intercepts are going to come from the top, and my vertical asymptotes are going to come from the bottom. So when I look at the numerator, is there an x in the numerator? No, therefore there is no x-intercepts. So for this one, it's none. Vertical asymptotes come from the bottom or the denominator. And when we think about our vertical asymptotes, if we look at that as a factor like this, you're always setting it equal to 0. So if this was set equal to 0, what would x equal? 1. And we need to remember that x-intercepts is where your graph lives. X is this. Your vertical asymptotes are where x is not. X is not going to be equal to positive 1. Now I'm going to say that this is how I remember it, that the top gives me x equals, the bottom gives me x is not equal. Now keep in mind, if they ask you for the equation of the vertical asymptote, it is an equals equation, but I just write it as not equals, so I remember my graph doesn't live there. So down here, when it asks for vertical asymptotes, I have to write it as x equals 1, but your graph doesn't actually live there. So the line is going to be x equals 1. Horizontal asymptotes, we have to think about those 3 situations that we jotted down at the top of the page. So in our notes, we just wrote down, and what situation is this? When we look at the degree of the top and the bottom, what do we got? Which situation? What? We've got a big old bottom. So when you've got a big bottom, it is 0. So we've got y is equal to 0 for my asymptote. I got a big bottom. However you want to remember it, y is equal to 0. Hello. Thank you. Danny and Hayden, I have a note for you. So I'm going to first sketch on my asymptotes, not intercepts. So I've got an asymptote. I'm not going to draw them as, well, I will. I'll draw them as dashed lines. So I have 1 at 0. And then I have my vertical asymptote is at x is equal to 1. I can't do a dash line. It's too hard for me with these pins. So I'm doing them as solid lines only because I'm doing them in pink, so you can tell that they're definitely different. They're definitely not part of my graph. My graph does not live there. However, when you look at any multiple choice question or you look up these problems, they are definitely going to be dashed lines. If you look in the solutions for today, they'll be dashed lines. So everybody know the difference? These are my asymptotes. They're pink. From here, I don't have any x-intercepts, but one thing that could be helpful is if I find the y-intercept. And to find the y-intercept, I have to remember that it's when x is equal to 0. So I'm going to look at the equation that I have, and in the numerator, I have a 1. I can't plug in x is equal to 0, so it's just, and I'm going to do this down here. My y-intercept. I think it's helpful to have your y-intercept to graph. So my y-intercept in the numerator, I will have 1. And in the denominator, if I plugged in 0, I would have 0 minus 1 or negative 1. What's 1 divided by negative 1? -1. So my y-intercept will be 0, -1. All right, that's really the only point that I can put on my graph. I'm going to have an intercept right there at -1. Now I'm ready to sketch on my graph. Is this a positive graph? Is it positive or negative? Positive, because there's nothing in the front saying that it's negative. So this is positive. And so because it's positive, my graph needs to end, and we end on the right. We read books from left to right. We read graphs left to right. So on the right, my graph has to be above the x-axis, and it has to follow the path of the asymptotes. So my graph has to end up on top of the x-axis, and it has to follow the path of the asymptote. So my graph is going to have this shape. So my branch on the right is going to have a shape like that. And this asymptote tells me I'm going to have two different parts to my graph. I'm going to have the graph that's on the right side and then the graph that's on the left side. That's how many branches I'm going to have. Your vertical asymptotes tell you how many pieces your graph is going to have. On the left side, I know that I have to go through that intercept. And I also know that this is a first degree. So my branches have to go apart. So this has to be facing down because they have to go apart. That's what happens most often. Your branches have to go apart, and I can't cross the horizontal asymptote. So I'm going to come up and and I have no x-intercept, so I can't cross the x-axis. I have to come up like this. So that's my basic shape of my rational function. You ready for the next one? Any questions over the first one? You can put the computer down. Any questions? Okay, for the next function, we've got to pretty much find all the same pieces. So we've got the numerator and the denominator that tells us different things. X-intercepts come from the top and vertical asymptotes come from the bottom. So go ahead and jot down what you think the x-intercept is and what you think the vertical asymptote is. You can also find the y-intercept and the horizontal asymptote. From the numerator, what is the x-intercept going to be? X is equal to what? -2. Very good. -2. It'll be the opposite. X is equal to -2. My vertical asymptote, X is not going to be equal to what? 4. And again, that's how I remember that that's an asymptote because my graph doesn't live there. My y-intercept, I can plug in zeros. So in the numerator, if this is 0 plus 2, I have 2 on the top. And then in the denominator, I have 0 minus 4. So I have -4 on the bottom. What does that reduce to? So my intercept, my y-intercept will be 0 and then -1/2. I'll have to split hairs here. If it's a half, it's somewhere in between 1 and 2. Sorry, somewhere in between 0 and 1 in the negative direction. Like it doesn't have to be exact. We're sketching. Horizontal asymptote, what situation do we have here? Looking at the degrees. Yeah, it's balanced. That's a good word. It's balanced. And so when it's balanced, you look at the ratio of the leading coefficients. So the ratio of the leading coefficients here, it's a 1/1, which is just 1. So these are the same. Sorry, I lost my mouse. It's the same or balanced. That's a great word. And so we look at the ratio, and so it's 1/1. So it will be y is equal to 1. That's our our horizontal asymptote. I'm going to sketch on asymptotes and intercepts. To be able to graph, you need to sketch on asymptotes and intercepts. That's what I'm going to do in no particular order. So I'm going to sketch on my asymptotes. I have a horizontal asymptote at y is equal to 1. So I'm going to put that on there. I have a vertical asymptote over at 4. And then my intercepts. I have an intercept at -2, x-intercept at -2, and then a y-intercept at -1/2. So just somewhere in between. It doesn't have to be exact. It's kind of hard to be exact when your graph is so tiny. I'm ready to graph. Is this a positive or negative graph? Positive. More often than not, they're positive. Not always, but a lot of times they are. So my graph has to end on the top of the x-axis. Okay, so on the right side, it has to end on top. So that means that, and it kind of makes sense based on where I put my my intercepts, that I can kind of tell that I'm going to have a branch over here because it's got to go through over there. So my right branch is going to be up here. Also, because I only have one vertical asymptote, I'm going to have 2 branches to my graph. So I'm going to have 1 branch and I've got to follow the asymptotes. I get close to, but never actually touch. And then my left branch, going to look something like that. Any questions over our second graph? We good? Is it starting to come back to you? Okay. And my third graph, what do I have to do first? Factor. Write that down. We already wrote it down once. Write it down again. The more times we write it down, the more likely we are to remember it. So I need to factor that denominator, and it's actually easy factoring. This should be really quick for you. To factor this, it's a difference of perfect squares. And so anybody know what this turns into? You ready? Yeah. What does our denominator turn into? You're killing me. Okay. It turns into x plus 3, x minus 3. And that's a pattern. Anytime you see something squared minus something squared. So if it was minus 25, then it would be x plus 5, x minus 5. If it was minus 49, then it would be x plus 7, x minus 7. Y'all remember? Remember it now? Okay. You're welcome. So I'm going to rewrite this. In the numerator, I have x plus 6. In the denominator, I will now have x plus 3 and x minus 3. I can almost guarantee you'll have something like that on your exam because it's easy, quick factoring. From here, we always want to take a look at our factors and see if once we did factor, are there any factors that are in the same in the numerator and denominator that would cancel each other out? And so do we have any repeated factors in the numerator and denominator? No. Okay. So we don't have any repeated factors. We're still going to find the same things from the numerator and denominator. From my numerator, I'm going to figure out my x-intercepts. And from my denominator, I'm going to find out my vertical asymptotes. So what is my x-intercept? I will have 1. What will it be? Yep, x equals -6. Very good. And my vertical asymptotes, x is not going to be equal to what? 3 or -3. All right. Down at the bottom, it asks for my vertical asymptotes. The actual equations will be equals. X equals -3 and x equals 3. My x-intercepts, we already jotted it down at the top. My x-intercept, x is equal to -6. I also find it helpful to jot down your y-intercepts like we did over here. So I'm going to plug in zeros to this and not this because I have more zeros to plug in over here. So if we find our y-intercept, if I plug in 0 to the numerator, I get 0 plus 6, or I get 6 in the numerator. And in the denominator, if I plug in 0, it doesn't matter if it's squared, it's still just 0. And so I get -9 in the denominator. How does that reduce? What do I get? Do what? Did you say 2/3? Okay, I thought you said 3/3, and I was like, no, no. 2/3. -2/3. All right, so we've got our asymptotes and intercepts. Ooh, we don't have a horizontal asymptote. We need to figure that out. For my horizontal asymptote, it didn't ask for it, but I feel like we need it to graph. What situation do we have over here? What situation? We're looking at the degrees. What situation do I have for the degrees? Big old bottom. When we got a big old bottom, it's 0. So my horizontal asymptote, big bottom. So when we have a big bottom, y is equal to 0. This is what happens more often than not. So it's a really good one to commit to memory. Big bottom is 0. So I'm going to sketch on my asymptotes and intercepts. That's half the battle. Asymptotes and intercepts. Horizontal asymptote at y is equal to 0. Vertical asymptotes at positive and -3. Intercepts. My x-intercept is at -6. And my y-intercept is at -2/3. Again, I'm not going to split hairs. It's somewhere in between 0 and -1. I have 2 vertical asymptotes. So if I have 2 vertical asymptotes, I'm going to have 3 branches to my graph. I'm going to have some graph over here, some graph in the middle, and some graph over here. So I'm going to have 3 different branches to my graph. Is my equation positive or negative? Positive. More often than not, it's positive. So if I'm positive, I have to end on the top side of the x-axis. So I can tell you that my graph, this first branch is going to look something like this. Okay, in the middle. And also, do I have any squared factors? Is this squared? Is this squared? No, nothing is squared. That means that as my graph approaches those asymptotes, my graph has to move in the opposite direction. So I know that if at this asymptote, if this piece of the graph is facing up, this piece of the graph has to face down, which makes sense because I have to go through this intercept. So my graph is going to face down, and I can't cross this horizontal line because I've got no x-intercepts. So I'm going to look kind of parabolic. So I'm going to look a little parabolic. I'm going to go through my y-intercept. What?
I'm talking the x-intercept.
Y-intercept at -2/3 right here. So I've got one y-intercept and then I have one x-intercept. My x-intercept is here at -6. And so at -6, I have to touch right there. But here's an asymptote. At the asymptote, nothing, I have no squared factors. So that means that at that asymptote, my graph has to go in opposite direction. So since this one is facing down, this one on this side, it has to be facing up. So it has to touch the asymptote, sorry, it has to touch the intercept. And it has to travel up. Okay, they have to go in opposite directions. Looking at my intercept comes from the top. This is not a squared factor. So that means that it has to leave that intercept and go in the opposite direction. If this was a squared factor up here, then we would bounce off the x-axis and continue up. It's not squared, so we're going to go through and go down, but still travel right along with that horizontal asymptote. Any questions over the third graphing? Hopefully it's coming back to you.
Enjoy graphing functions. It's like you got the horizontal aspect, but whenever it's zero, you kind of just break it.
Every now and then, yeah, we can break the rules. Yes, we sure can. And we're going to talk about that. So here's some 3 examples to help us get in the mood. On to the back. Well, I'm sorry, you've got this question down at the bottom. Down at the bottom, right? Isn't this down at the bottom? Okay. The rational function will have vertical asymptotes at what? We've already kind of done this. When do we have vertical asymptotes? It happens, vertical asymptotes come from the denominator. So it's anything that makes the denominator 0 will cause a vertical asymptote. So that's all I'm going to write down. Anything that makes the denominator equal to 0. Any number that makes the denominator equal to 0. So anything that makes the denominator equal to 0 is going to cause a break in your graph or a vertical asymptote. And then the questions continue on to the back. I had to try and make more room on the back for us to graph. On to the back, it says, use your conjecture to predict where the rational function, this one, will have a vertical asymptote. Before we can even identify where this vertical asymptote will be, which we know they come from the denominator, what do I have to do first? We've written this down twice on our notes. What do you have to do first? Factor. Okay, you have to factor. When we factor this, this is a difference of perfect squares. We've already factored this. We're going to have x plus 3, x minus 3, and you can switch the order. It can be x minus 3, x plus 3. It doesn't really matter. So we get in the numerator, x plus 3, x minus 3. Before we factored, we had an idea. We should have a vertical asymptote at positive 3. But now when we take a look at our equation that is factored, anybody notice anything? Any repeated factors in the numerator and denominator? Yes. So this cancels out. And what this causes is that I'm taking this out. So it creates a hole. This creates a hole. It creates a hole. The next question talks about create a rule. Yeah, we're just going to name it. We're not really creating a rule. We're just naming it. And you may have learned this last year. But what happens when you remove this factor? So we're canceling it out. We're removing it from our equation. It's called a removable discontinuity. And so the word is right here if you need to know how to spell it, but it is called a removable discontinuity. A removable discontinuity. And you need to know that it's because we removed that factor from the numerator and denominator. It's removed. And that creates a hole. And so we're actually going to sketch this graph over here. It says graph it to see what it looks like. So there's a little bit of room on your notes that we can sketch this graph. So I'm just going to sketch an X and a Y. I know that the hole is going to happen. We're going to have a hole at +3. We're going to have a hole at +3 at X equals 3. So I know over here at 3, I'm going to have a hole. What I end up with is just X plus 3. That's the graph of a line. So the graph of a line, I'm going to cross my, I'm going to cross my y-axis at 3. We have to remember how to graph a line. My y-intercept is going to be at 3, and then my my slope is up 1/1. So I'm going to cross over here at 3. And then I'm going to be traveling up 1/1. And so I'm going to just estimate that I'm going to have my hole somewhere like that. So this is what I get is a graph. And you'll notice on your solutions that to show a hole, it's literally just that. It's a little hole. There's a little hole in your graph. So anytime we remove a factor, it is a hole. And so it's no different than if you just started out and you were like, oh, there should be a vertical asymptote at +3 because X does not equal +3. That's still kind of true. X does not equal +3, but it's not an asymptote anymore. It's now a hole. So it's a little bit different. You have to make sure that you factor so you can identify these things. Any questions? Okay, moving on. Question number 6 says, look at the 3 graphs that we did graph. See if you can articulate your findings about horizontal asymptotes and end behavior. You already did these notes. The notes are on the front. The notes are on the front. You already sketched or you already wrote out and gave examples of horizontal asymptotes and in behavior. Next, do you think it's possible for the graph of a rational function to intersect its own horizontal asymptote? Why or why not? If you think that it's possible, see if you can find such a function. Clayton already kind of talked about this. Is it possible? Yes, we're going to write that down. Yes. Which graph did that? Yep. Yes. Graph number 3. Graph number 3, but it is important to note that this can only happen. Only time it can happen is if your graph needs to get to the x-intercept. Okay, so this is really important. You can cross a horizontal asymptote if there is an x-intercept. That's the only time. So the graph can only cross a horizontal asymptote to get to an x-intercept. This is rare. It doesn't happen very often. It's rare. Asymptotes are pretty strong. They will attract the graph, but your graph doesn't usually touch the asymptotes or cross them. But horizontal asymptotes are weak. You can penetrate the horizontal asymptote if and only if you have to get to an x-intercept. The next question, that kind of leads into the next question. Do you think it's possible for the graph of a rational function to intersect its own vertical asymptote? Do you think it's possible for a rational function to intersect its own vertical asymptote? Why? Okay, no, because we've never seen it happen. And that's true. No, never. Absolutely not. Never. And there's a very specific reason why. The reason this never happens is because if you did cross if you crossed a vertical asymptote, you would no longer be a function because you would overlap on yourself. So never, because it wouldn't be a function. Okay, you can cross a horizontal asymptote and still be a function. That's why it can happen. You cannot cross a vertical asymptote because if you did, if you have two graphs that come up to a vertical asymptote, if they crossed, you are no longer a function. Okay, moving on. We have a couple more graphs that we're going to do. These are a little bit more exotic than the first ones that we did on the front page. And before we get started, did y'all do Rete last year? Did he teach you Rete? Oh my gosh, he's even got notes for Rete. That's really cool. I might need to make copies of that. How did you know to have those for today?
I just keep them in my backpack in case
In case you need random Rete notes? This guy. So Rete. And I didn't even know that thing that existed, but I can already tell, even without seeing it up close, it's good stuff, and I'll make copies for everybody. What I would like for us to write down is this. Rete, if you've never seen it before, stands for roots, asymptotes, togetherness, and behavior, and y-intercepts. I really like to add fa-ha to my Rete, fa-ha-rete. Because you have to factor and you have to check for holes. So jot this down.
What kind is this?
On-ramps.
Oh, that's expensive.
Because
Of course, you put the strawberry in.
Did you drop one of my neck?
Did I? No, I don't think
Will you
so.
get this clear one?
Oh, I didn't even see that. Oh, nice little. You got this very last year?
Yeah.
Okay, you go.
my family. I know it's nice and snuggly in here.
Like,
It's always nice and happy.
it's always cool. Like, this is like the most calmest classroom I ever did.
I know that's it's supposed to be like that. I spend a lot of time in here.
I remember coming here last year. We always messing with that. Always. And that was the Penfuse is my favorite.
I know. I thought for a second it wasn't working yesterday, but it does work. I was just doing it wrong. Okay, did y'all write this down? Happy Thursday. So this is just to help you keep things nice and organized and help make sure that you're finding all the pieces that are important before you graph. And so first, are you factored? Are there any holes? So looking at my first equation, is it factored? Anything I can do to factor that? No, we're good. It's factored. Are there any holes? No. So, I mean, I like to go through the motions. It's factored, holes, none. I don't ever put zero because to me that implies there's a hole at zero. So I just say none or no. Moving down the list. So I have it written like this on purpose. This tells me that roots come from the top, asymptotes come from the bottom. So roots come from the top, asymptotes come from the bottom. Also, one thing that you can remember is these are x equals or not equals. This is x and the bottom two are y. This one has a y. So these are x's, these are y's split by the t. So roots come from the numerator. From the numerator, I know that x is going to be equal to what? 5. From the denominator, I know that x is not going to be equal to, but we know that it is actually equal to if you have to do a test. But I like to remember it as my graph is not equal to 1/3. Good job. Togetherness. Togetherness only happens when you have a squared factor. Are there any squared factors? No. So no togetherness. No togetherness. E is for end behavior. So we're looking at the degree of the top and the bottom. The degree of the top and the bottom. What do we notice about them? It's balanced or they're the same. So we're going to look at the leading coefficient of the numerator and denominator. So we have a 1/3. So my end behavior, and again, this is a y equals, y is equal to 1/3. Last, my y-intercept. So y is equal to, and I'm going to plug in 0 for x. If I plug in 0 for x in the numerator, I get -5 divided by, if I plug in 0 here, it doesn't matter if it's multiplied by 3. I get -1. And -5 divided by -1 is +5. So my y-intercept will be 0, +5. Sketch on my intercepts and asymptotes. I'm not going to scale anything, and that's all I'm going to label because that's all that I care about. So my intercepts and asymptotes. Boys, are y'all graphing? You should be. My y-asymptote. So it's a little bit above the x-axis. So I've got y is equal to 1/3. My x-intercept is at 1/3. My intercepts, I have 0, 5. And 5. All right, from here, I'm ready to sketch on my graph. Is my graph positive or negative? Positive. So if my graph is positive and I have to touch this intercept, I'm going to leave the intercept and I'm going to head up, but I have to follow the path of the asymptote. So I'm going to head up and go like this. And because there's no squared factors, I'm not going to bounce off. I have to go through and follow the asymptote this way. So I'm going to end up with a shape on the right side of the asymptote that looks like that. There is no togetherness. So at this asymptote, there's no togetherness. So since this one is facing down, I have to hit this intercept and head up. Also, it would cause me to cross a horizontal asymptote, and I can't do that because there's no intercept. So again, I want to point out that around this asymptote, I went apart. Moving on, question number 8. So question number 8, am I factored? Yeah, I'm factored. Are there any holes? Is there a factor on the top and on the bottom that can cancel? No holes. Roots come from the top, asymptotes come from the bottom. Roots on the top. Is there any X in the top? No. No roots because there's no X in the numerator. Is everybody listening? Because I don't feel like everybody's listening, but I don't feel like the people not listening necessarily know what we're doing. So it's a good idea to be listening. In the denominator, my asymptotes come from the denominator. So what are my asymptotes? X is not going to be equal to what? -2. Is there any kind of togetherness? Yes, for this one, it's the first one that we've done with a squared factor. So we are going to have togetherness at -2. So togetherness at X is equal to -2. That is important to know. We have togetherness at -2. In behavior is looking at the degree of the top and the bottom. There isn't even an X in the top. So we're definitely bigger in the bottom. And when you're bigger in the bottom, when you got a big bottom, it is 0. So Y is equal to 0 is my end behavior. And if I plug in 0 for X, in the numerator, I have a 6. There's not even an X to plug 0 into. In the denominator, if I plug in a 0 here, so this one's just a little tricky. If I plug in 0 here, I get 2. But I have to remember it's 2 squared. So it's 4. And 6 over 4 reduces to what? Yep, 3 over 2. I'm ready to graph. I'm going to sketch on my intercepts and asymptotes. Intercepts and asymptotes. In behavior, Y equals 0, -2. Intercepts, there's no x-intercept, but we do have a y-intercept at 3/2, somewhere like that. Is my graph positive or negative? My graph positive or negative? Did I hear negative? Where are you even getting negative? There's not even a single negative in the problem. It's a positive. It's a positive. More often than not, it is positive. The only way it would be a negative is if one of these factors were negative. Like the leading coefficient has to be negative for one of them. So positive. If I am positive, that means that my graph has to end above the x-axis. And that makes sense because I have an intercept right here. So I'm probably going to have this type of shape and follow my asymptotes. I have one vertical asymptote, so I'm going to have 2 branches to my graph. So my graph will follow the path of the asymptotes and look like this. I have togetherness. It's the first time I have togetherness. That means that around this asymptote at -2, that my graph has to go and it has to leave and go in the same direction. So since I'm pointing up on the right, I am also going to point up on the left. So my graph has to leave and go together, but it's going to follow the path of the asymptote. And maybe it would be a good idea to jot down that this is together. So again, this is apart. You go in opposite directions, and this is together. We've got one more graph here that I would like to quickly do before we get out. What do we have to do first? Factor. Well, we already factored this. So I'm going to jot it down. We already did this for like a warm-up. So we get 2x minus 5 times x minus 3, and then 3x minus 5 and x minus 3. So we factored. Are there any holes? Yes. So we have a removable discontinuity. So we have a hole at x is equal to 3. We have a hole at x is equal to 3. That's important. I'm just going to go ahead and jot down that because I don't want to forget there's a hole when I go to make my graph. Roots. Roots come from the numerator. So in my numerator, if I solve this or set it equal to 0, I would get positive 5 divided by 2. So x is equal to positive 5 divided by 2. Don't be afraid of fractions. We can estimate 5 divided by 2 is about 2.5. And I don't have anything scaled, so you don't got to stress about that. Asymptotes. Asymptotes come from the bottom. And in the bottom, if I set that equal to 0, I would get positive 5 divided by 3, which is going to be less than 2.5. So important to keep in mind. So x is not going to be equal to 3. Sorry. Oops. 5 over 3. Togetherness. Do I have any togetherness? Do I have any togetherness? Any squared factors? No, so no togetherness. In behavior, so looking at the numerator and denominator, same degree, it's balanced. So we have to look at the ratio of the leading coefficients. So my end behavior or my horizontal asymptote will be y is equal to 2/3. And then last for my y-intercept, I don't want to plug x's into all of this, but I could. If I plugged in plugging in zeros, you can plug it in here or you can plug it in here. It doesn't really matter. If I look at my y-intercept, all of these terms cancel and I'm left with 15. Same thing with the denominator. These terms cancel and I'm left with 15. 15 over 15 is what? So my y-intercept is 0, 1. I have everything I need to sketch on my asymptotes and intercepts. Asymptotes and intercepts. Asymptotes. I have an asymptote at 2/3. A y-intercept, a horizontal asymptote at 2/3. And then a vertical asymptote at 5/3. My intercepts, I have a y-intercept over at 1. And then I have another I have an x-intercept at 5/2, so about 2.5. So it's going to be in between the asymptote and the hole. All right, is this positive or negative? You look at the leading coefficients. Is this positive or negative? Positive. Okay, so if it's positive, it has to end above the x-axis. So it's going to touch this asymptote and head up and make that branch. But I have a hole, so I'm just going to estimate this hole is going to be, I don't know, about there. And then it's going to follow down my asymptote. My left branch, there's no togetherness, so it's going to have to hit this intercept and head up. And that will be my second branch. One asymptote, two branches. Beautiful. Sorry that was long, but we are done for today.